Hi guys, so in this lesson you're going to be comparing functions using average rate of change, which is also known as your slope. So you can pause the video here to really read the two bullets, but all that's saying is that your exponential functions are going to exceed eventually your quadratic and the linear functions, and then your quadratic functions exceed your linear functions. That's all it's saying. So we're going to look at the first question. Two social media websites open their memberships to the public. Part A, compare the websites by calculating and interpreting the average rates of change from day 10 to day 20. So what we're going to look at is basically the slope. I'm going to take website A and I have the 2 points from day 10 and then day 20. I underlined the 2. So we have the two coordinate pairs, which is 10, 1400 and then 20, 2150. So all we do is change in y over change in x. So we have 2150 over 1400, and then or 2150 minus 1400 over 20 minus 10, which is equal to 750 over 10, which is the same thing as 75. What that means is from day 10 to day 20, your interval, your average rate of change was 75 people per day. So that's website A. We're going to look at website B, and website B, you have to go back to the graph. So if you have to rewind to see the graph, please do so. So website B says that for day 10, you have about approximately right there, which is about, I would say, I don't know, it's in between 600 and 1200, so I'm going to say 850. So 10, 850. And then the other point would be 20, so day 20, and that's at 1800. So 1800 minus 850 over 20 minus 10, that will give you, the difference of the two is 950 over 10, which is 95. That means from day 10 to day 20, website A has membership increases at an average rate of 75 people per day, and then website B has 95 people per day. So website B is obviously growing a lot faster. So to answer part B, which was predict which website will have more members after 50 days, explain. You know that exponential functions will eventually exceed any, so quadratic or linear. So it looks like website B will exceed in the end. So after 50 days, it will have more members. So website B will have more members. But it does look like after 25 days, the membership of both websites are about equal. But in the end, it'll be that website B will exceed website A because it's an exponential function. For our next question, it has 3 parts, and I think it's best to follow along with your graphing calculators. So take them out and pause the video. So in this question, in 1900, Littleton had a population of 1,000 people. Littleton's population increased by 50 people each year. That's the slope right there. In 1900, Tinyville had a population of 500 people. Tinyville's population increased by 5% each year. So in what year were the population about equal? Use your graphing calculators. What we need to do, first step, is to figure out the two functions. So we're going to write the two functions together. I'm going to call the first one L of x for Littleton population. So L of x is equal to, and we know that this is a linear function because each year, 50 people. So the population is increasing by 50. So that's your slope, 50x, plus the 1,000, which is the initial population. That's your L of x. For your T of x, your Tinyville's population, you need to know and remember your exponential growth function, how it looks like. And you know it's increasing by 5%. So we're going to start off with your initial population, which is 500 people. So 500, open parenthesis, and this is increasing your growth. So it's going to go over 1, which is 100%. So 1.05, and you're going to write the x as an exponent. So that's your T of x. Now what we need to do is plug it into the calculator because it does say use graphing calculators. So take out your graphing calculators and go to y equals. And basically plug in those two functions. So 50x plus 1000, and then t of x is, put it in y2, which is 500, and then in parentheses 1.05 to the power of x. And then hit graph. And it looks like it's not graphing because it's out of our window. So I'm going to play a little with zoom. So I think zoom fit will work. That's where I go first. So zoom and then press 0, fit. And it does give you two functions. However, we don't see the intersection. So what we need to do is probably zoom out. So zoom and then number 3, zoom out. And then I'm going to move with my arrow to, a place where I think they might intersect, and it'll zoom out there. So press enter and I get two intersections. First, I'm going to show you what not to do, but let's find the intersections. So what we're going to press is second and then trace button, which is calc. So second is your blue button, so press the blue, second, and then we're going to press trace to find the intersection. And we know that our intersection has to be in quadrant 1 because we're talking about population. But let me show you what you should not do. So second, intersect, which is number 5. And then I'm just going to press first curve, enter. Second curve, it goes to the other functions, enter. And then guess, enter. My intersection, my x became a negative number. So that is what you should not do because we need a positive. So we're going to go back, second trace, and this, or second calc, and then I'm going to move with my arrows to that, close to that intersection in the first quadrant. Then I'm going to press enter for the first curve, second curve, enter, and then enter again to guess, and that's my intersection. It says x is about 34.9, so I'm going to round it to 35. So x is close to 35, which means in what year were the population about equal? And this question started graphing it starting in 1900. So if my x was about 35, my population of the two cities, or Littleton and Tinyville population, will be about the same in 1935. So part B. Suppose Littleton's initial population doubled to 2,000, that's the initial, and maintained a constant rate of increase of 50 people each year, just like the beginning. Did Tinyville's population still catch up to Littleton's population? If so, in which year? So my y is equal to, or same thing as L of x, now became 50x plus 2,000. My initial became 2,000. And then my t of x is the same. So 500 times 1.05 to the x power. So I'm going to go back to my graphing calculator, just change 1,000 to 2,000, my initial population. And it's going to give you that graph. I'm going to hit zoom again, zoom out. I want to see just the first quadrant. That's all I'm interested in. Positive values. If I move with the arrow and then zoom out, that's my intersection. So second, calc or trace button, and then number 5, intersect. First curve, they ask you, it's already near the intersection. Second curve, enter, and then guess, enter. And then my x is about 43.5. So in which year? So x is approximately 43.5. So in year 1943 would be when the Tinyville population catches up to Littleton's population. And last part C, suppose Littleton's rate of increase doubled to 100 people each year. In addition to doubling the initial population, did Tinyville's population still catch up? And explains. So my L of x is equal to 100x plus 2,000 because it became from 50 to 100. I'm actually going to call that not L of x, but g of x because this is a new function. even though it's still Littleton's population. Then my t of x is the same because we're trying to compare from the original. 500 times 1.05 to the x. Plug that into the calculator. Now you know what to do. Fix 50 to 100, and make sure you do second insert. If you're not going to rewrite the entire thing, make sure you insert it because it's going to erase the numbers. It looks like it gives you the graph right away. So second trace, first curve, second curve, guess, enter, enter, enter. Intersection would be 55 point about 7, right? If you round it to the nearest tenth. So Tinyville's population caught Littleton's population in 1955, let's say, or 1956, depending on what you would say. Because Littleton's population increased linearly and Tinyville's population increased exponentially, it'll always eventually exceed Littleton's regardless of the constant rate or the initial value. And that's the whole purpose of these 3 parts. And for you to practice your graphing calculators. I hope this lesson made sense. And if it didn't, you need clarification on some parts, make sure you reach out. Okay, great job today. I'll see you next time. Bye-bye.